Я действительно сегодня пришел рассказать про фазеры. Я пришел...
I'm here to share with you something that I know about fuzzers. I like working with them from a research, from an academic perspective. But let me introduce myself first. I've been in the coding business for the past 10, even 11 years, and during the past 5 years, I started working on dynamic coding.
Привнес профилятор в IntelliJ ID, поэтому...
I'm the person who introduced profile in Inteller ID, and if you don't like how it works, please send me your feedback. In the last couple of years, fuzzers have been in the focus of my attention. I really enjoy this work. I noticed that people do tend to get confused about fuzzers. Well, fuzzers, when and where they are applied, they are perceived as something complicated. Besides, fuzzers are used in rather specific tasks. But today I wanted to give you the basics of fuzzers to explain how they are constructed, and maybe I will be able to convince you that you can start using fuzzers tonight. You can go home after this conference, start the laptop, and work with a fuzzer, try to do something. Fuzzer is a utility to test apps. Its main technique is fuzzing.
Перейти от слова фазер.
And now, from the word fuzzer to the word fuzzing. Fuzzing is a testing technique. In general terms, this technique can apply anywhere. You can test software, you can test an app, you can test Linux kernel, or and you can use languages, Java, C++, any other language or any other area. Why not? Wikipedia gives you a longer definition, but what is important is that fuzzing is a testing technique that sends in some random and unexpected data as input to an app. Let's see how this works in practice. There are two ways to apply fuzzing. You can try to write everything from scratch. But the problem here is obviously you need to understand how it works. Or you can take a fuzzer off the shelf, writing from scratch, a greenfield project, so to say, has its pros. You, in your project, can use specific compilers that will fit just that project. Now you can code a fuzzer that will apply to this compiler. But if you take something out of the box, then yes, these fuzzers also exist. Here are some of them. FL++. It's the successor to the archived AFL project, which first emerged in 2010s. This is when the interest to fuzzers was reignited. FL++ at the moment is quite a thick library, and it can do many different things, and yet the LLVM libfuzzer outshines AFL++. Libfuzzer is an easy-to-use tool, and tools in other languages also appear that use libfuzzer at its core. They create a lab layer substack, maybe. So you find the Python versions and JavaScript versions of libfuzzer these days. Libfuzzer is also a convenient utility, a convenient piece of software. Oh, and by the way, this is the link to the presentation. Andrei has just talked about LLVM and what this project is. And what we are interested in is that your fuzzer can be used on your CI/CD. GitLab has already embedded the fuzzer support on the platform. There are commands that can be written in one-string files, and you can test this piece somewhere for your project, but on their hardware. You will not need to do anything on your side in terms of setting up the infrastructure. And then there are also other interesting projects in the Java world. CI of Fuzz is the company that developed Jazza and its version for JavaScript. This company is probably an excellent example of why you might want to write your fuzzer from scratch. Jazza, that used to be open source from the beginning, a couple of months ago, they acquired a tab that says we no longer support the open source component. There is Jazza Pro. Come to us and buy it. This is all you need to know about this company, and this is how they are developing their fuzzer at the moment. And the fuzzer is okay, by the way. OSS Fuzz is a Google project. It is their response to the Heartbleed vulnerability that was registered in 2016. So what they did, under their umbrella, they assembled different open source projects. They used their capabilities to test different fuzzers. You have heard about this other vulnerability in the archive, and the person who introduced the backdoor to this archive came to SSFuzz and requested disablement of this library from OSS-Fuzz. It's a dramatic story. You can read more about it online. I'm not going to retell everything right now.
Для того, чтобы понять, что такое фазинг, конечно же, хотелось бы начать где-то там с истоков.
Let's start at the beginning. 1988 is considered to be the birth date of fuzzing. This gentleman called Bond Miller.
На страничке университета которого очень...
And at his university page, you read that he founded
тестирование с помощью фазеров.
The fuzzer testing industry, but his name is associated with this software testing technique using random data. But not everybody agrees with that. There is another gentleman called Gerald Weinberg said that we did this already back in 1950s, and this is how we did it. We had these punch cards. We took these punch cards, put them into the machines, and when we wanted to test the software or a program or an algorithm, we would take these punch cards out of the garbage bins and install them. And of course, they had other punch cards that were pre-written with random data. They didn't call it fuzzing. They called it the garbage bin or recycle bin technique. To go back to Bart Miller and why I think that his example is a better illustration to fuzzing, in 1988, he was a professor at a university, and he offered several themes to his students as themes for annual work. And one of such themes was a fuzz generator. You don't need to read everything. You can find the whole text later. But let me highlight the words that I'm interested in here. The fuzz generator. Well, first of all, that's the phrase that is going to be replicated across the world. Then he explains why this project, to evaluate the robustness of various Unix utilities. And then he explains how we do it. We generate an output stream of random characters. And then he says that we use it to test various utilities like make, set, sort, etc. And then he says, if there is a failure, we would like to see what error, what type of input was responsible for the error, for the failure. So that's the background of fuzzers, and probably this is how you could have generated this algorithm. And a couple of years later, he wrote a scientific paper where he described the results of these annual or yearly projects from his students. He says there is a fuzz, a set of parameters, input into a software, into an algorithm. And this is the modern definition. This is the one I like the most right now. If you would like to find out about fuzzing, I suggest that you read this paper, because there you'll find lots of stuff about machine learning, symbolic analysis, etc. So the authors are trying to articulate what fuzzing is. The paper is called The Art, Science, and Engineering of Fuzzing. And they say that fuzzing is the execution of the put using input sample from an input space that protrudes the expected input space of the PU of the put. So in the English version, it's as confusing as it is in Russian. So the idea is there is an input for the code. You say that your code will accept these inputs, and you can generate more inputs of a particular type, which is only natural. And there is a percentage of those inputs that will generate issues for the code. And this percentage may be part of the universe of the expected universe, or it can be an input from the greater universe, not from elsewhere. The simplest fuzzing will look like this. We'll take a random number generator or random data generator. There is a code, and we feed it into the code, and we expect an error to be returned. Anyone looking at this may have a question. The question is, what is an error? What do you consider to be an error? Do you know what kind of errors this one may lead to? Overloading, overflowing, and? Yes, maybe. But this is Java Kotlin. But no, that's why you can't. Any other ideas? That's right. Null. That's right. 2 errors. We are not testing for null, but no one is testing for null. At least in Java, there is a convention. If it's an array, some array, no one is testing for null. And the other one, someone said, overflowing. We can sum up the values into a variable. This result is an integer. Sooner or later, we'll run out of integers. But when these 2 errors are identified by a fuzzer, your senior developer comes to you and says, what are you doing? Why null? Why really null? We are summing up the age of the students of one group. You will never have overflowing there. So this is conflict number 1. So we have to make this setup a little bit more complex and move on to the second definition from the same paper. I refer to fuzz testing. They say fuzz testing is the use of fuzzing to test if put violates security policy. That's why we add a security policy. It can be any security policy. Say, there is an error, or in the code there is an out of memory that leads to this code writing some file outside of the directory, trying to upload it somewhere over the socket. I don't know, security policy of this kind. This is what security people do when they try to understand whether an error is a vulnerability potentially or not. And we will cycle this. We will put it into a closed loop. I mean, the fuzzer, not to restart it every time. Is it going to work? It's a test for you. I've got students, like I said, I teach at a university, and one of the problems I ask them to solve is to do a team sort.
Все мы были студентами,
We all were students.
мы знали, что достаточно
We knew as students that it's enough to find software somewhere online that works, change the words there, change the structure,
обманутый, поставит вам пятерку
and the professor is going to give you an A
в интернете. Я вот нашел
because the professor will be deceived. And I found this project.
реализацию разных сортировок для разных языков программирования.
This is different versions for different languages are gathered. Team sort and Java, the two words are used. Team sort, I found this repository because this word is in the source code for Java. And I wrote this fuzzer.
Использует рандом.
Here, fuzzer uses random to generate random values. And after that, the array is filled out with random values and random lengths. The array is generated, and after that, the array is returned. Will the fuzzer find this error? Yes, it will, because otherwise why I'm here with this example, if it were not working. So what do we have here?
Массива
Here is an array.
в ходе той программы где-то там
As the code is executed, there was an attempt to create an array and import negative array size exception onto this array. Where is the error?
писали студенты
I'm a good professor, and my students are also good. In order to test whether my students actually copied the solution from somewhere, I can run this code. If I'm returning, if I'm getting this error, then probably the paper was copied from somewhere online. I'm sure that those who did this code for TeamSort, they tested their software, their code. It works for an empty array, it works for smaller arrays. With the bigger ones, it breaks down. Vladimir is going to speak later, and he'll explain how he was writing a big sorter for Java. I'm sure that he's going to share his tips and tricks as to how to do this properly and not to break anything in the process. So we've got a fuzzer, and now with this fuzzer you can go home and play with it and check your project. I'm sure it's going to find something. Most likely it's going to find something. So what is the problem that we can find quite quickly if we attempt to apply a fuzzer? So here is a universe of values that the program expects to see as an input, and this is the area that we can generate in general. What if the values space is much smaller than the value space that we can generate in general? In 99% of cases, we are going to get nonsensical results that will make no sense to us. Like HTML, if you write your parser, what is the probability that if you generate a random string, real HTML will be produced? So what do you do in those circumstances? Let's try to improve our fuzzer. And here, difficulties start. This is the story that I love telling.
easy to start, hard to
Easy to start, hard to master. Like in gaming,
сидел.
or when I was studying algebra, you keep watching the professor explaining things, you think that you understand something, and then you sneeze, you are distracted for a second, you return your attention to the professor, and suddenly you understand nothing because you missed 30 seconds of his explanation. So here, just like with all these ideas, I mean, an idea is an easy thing to propose. I mean, you can generate lots of ideas in a second, but when you start looking into these ideas, you will see that there will be many different pitfalls in various ideas, and you wouldn't know how to overcome these barriers. Just like in this generator, if you write string generator, it doesn't mean always, you don't understand always how to make sure that this generator works correctly. Like this parser, HTML parser, stream page. So the first idea is to write a generator that will make HTML pages.
Еще предстоит выйти
Disregard the difficulty of understanding how to code for such a generator, but you know grammar, you know stuff. You go to the HTML specification, you write the grammar, you code the generative generator that will generate this grammar and HTML based on this grammar. Okay,
Так, если вдруг у вас такая идея появилась,
if this is your idea,
у вас одна.
then you're not the only one who had this insight. It's called grammar-based fuzzing.
Фазинги — это то,
The problem with this fuzzing is that
не совсем так работает.
fuzzing doesn't work like that.
Потому что мы же говорим, что мы же хотим
We are saying that we want to generate a set of data that would be random for this code, but we are instead generating something that the code expects to see as input. So what do? Random generation doesn't work because it will generate 99% of nonsense. Generate just valid HTMLs? Well, some errors will be detected, but probably not all of them, and we would like to find as many as possible.
нам остается,
So what is left for us to do?
остается применить такую технику, которая
Well, we can apply a technique that's called mutational fuzzing, mutation-based fuzzing.
месте генератора случайных данных
So we've got this random data generator, and we replace it with this. We've got some generated samples. You can take them from anywhere. You can write them manually in advance yourselves, or you can generate them on the spot with an HTML generator. And we can slightly modify these samples. When you modify a symbol slightly, or you remove a symbol, which you can do with a valid HTML, you can make it invalid. Instead of a closing tag, you remove one slash, and your HTML is no longer has a closing tag. Would you be interested to see how the parser would respond to that? Of course you would. Next question.
эффективной мутации.
Are mutations efficient?
Вот наша программа.
This is our code.
Что мы о ней на сегодняшний день знаем,
All we know about it is that
может как-то работать.
this code works.
Данные, и она как
It can be fed input and it can produce an output. That is normal behavior. We can approach it from a different side and we will not notice a difference. Even if x1 be replaced by x2, even if we mutate the x1 value and get an x2 value, the behavior will be the same. But only x3, when it mutated out of x1 or x2, generated an error. And there are only two types of behavior. This is called black box testing. If for some reason you forgot its proper name, we have two types of behavior, and it's difficult to say which of the sets we should keep and which ones we should disregard. But mutation is quick. Fuzzers can call 100,000 the target. They can call the target function 100,000 per second, and even more often. Now we turn to dynamic analysis.
значит, еще
I love it dearly. I first came across it at JetBrains. And in dynamic analysis, different, again, techniques are used in order to investigate the code from the inside. So what happens there, which functions are called, how much time it takes. There will be a presentation on profilers a little bit later.
Алексей, который расскажет,
Alexei is going to talk about sampling profilers, flame graphs,
можно оценить.
and how codes can be assessed.
Нас будет интересовать не
But now we are interested in this component, code coverage. Many of you did coverage testing, and probably you understand what it means. We need to understand which codes of which strings in our code were truly covered. We want this information to be able to differentiate between the code behaviors.
HTML наш парсер,
If our pass starts with an invalid HTML, we'll see an error. This is the wrong HTML, and it will not get us far. But if we have an HTML that goes through many iterations and it fails somewhere towards the end, then of course it will be an invalid HTML, but it will fail much later. And we're interested in seeing those errors because this error happened not in the beginning of the cycle, but towards the end of the cycle. And in our fuzzer, we are going to collect these kind of problems, the problems that are different in coverage. And the objective of the fuzzer is to increase the coverage. People are convinced, at least, that if you cover all of the code 100%, then this way you'll be able to detect all errors. You can agree with that or disagree. It's a mutable issue. But for now, let's see how can we achieve code coverage.
Для этого существует инструментация. Инструментация очень
Instrumentation exists just for that. It's a tool. It's a simple and a complex tool at the same time, especially if you write one yourself.
Многие из вас уже
And many of you probably did the instrumentation. Probably you called it not instrumentation, you called it debugging, console debugging or something.
system out там println.
When you're in school and you write the println and answer the variable value. So the more powerful
Они могут
instrumentation tools can add instructions at the stage of compilation. So you've got source code, and they start adding instructions to your source code, like Clang.
так и может работать.
I believe that this is how it works. And there are other instrumentation ways. Like you take a binary file, you decompile it or disassemble it with a disassembler, and then you introduce instructions, and then you assemble it back. It's another way to do instrumentation. Another option is Java.
Загружает каждый кусок программы.
That uploads each part of the code separately as a class, and it has an inbuilt mechanism to intercept the loading and to inject interesting stuff in it wherever you want. Anyways, when we've got instrumentation,
Нашу программу, что она нам стала чуточку прозрачной.
this code becomes slightly more transparent.
Понимаете теперь.
And you see how this code runs with this input. 100 milliseconds, the cycle ran for 1,000 times. You have an idea. Oh, here is x2, another trajectory. x3, yet another trajectory.
И для нас
And for us,
вот те вещи, о которых
these will be different sets,
вести как зерна, еще что-то, я
seeds.
понятно. Вот.
They are different seeds. That's what how they are known.
Так-то существует, помимо вот этого принципа, который в фазинге называется принцип сервера.
In fuzzing, you also find gray box fuzzing, but on top of black and gray box fuzzing, there is also the white box fuzzing. Usually here you have the original code that you can analyze statically and find errors. There are many different techniques of this kind, but they have the same issue. Even if you find a failure shown here in red, you will not always know what input the code requires, so for it to lead you to this particular error.
In any case, I'm not gonna deep dive into fuzzing with static analysis because there are lots of abstract interpretation of the of code, the taint analysis, and stuff like that. These are interesting things, but leave them for later. Right. So we discussed with you the common components of a fuzzer, And I hope I'm successful in driving the message home that fuzzing is a simple and an obvious idea. The only thing you need is to collect the right tools for your fuzzer. I did not mention too complicated things because you're constantly told about them by other presenters. However, if you need a fuzzer, what you need are the following ingredients: something that we can launch. It could be anything. It could be a program or a function that we're going to test. I already gave you an example. It could be a service such as HTTP. For instance, you run a fuzzer for HTTPS server. HTTPS service tries to respond. You analyze an error. I never did that. I don't specialize in that. However, I heard there are techniques to obfuscate problems when hackers try to find out whether there is a user with a specific username. So when they send a request to log into a service, they evaluate the response time, and the longer the response time, the higher the probability is that the program is trying to find this username in the database. So there are different metrics based on the uptime. And I even heard that developers slow down the response time of this service so that it is fixed. So if you have a slow internet connection, maybe this is done for a reason. Another important workstream of fuzzing compilers, what we do is we just fuzz a program in a language that we will use in the compiler. The very same errors will be highlighted. It's another interesting domain. Input data and their generator, this is an obvious thing, and we also need to be able to track the operation of the fuzzer. There are lots of buzzwords such as metrics, uptime, status, and so on. However, the main thing you want to understand is how to track the operation of a program. I already told you that you can use instrumentation and you can use a program compiled as a program. What if we need to work with HTTP service? What should the metrics be? I guess we need to come up with something. The next bullet is data storage. And seed storing in some database, because fuzzers are convenient because they can run easily. You can run them on a huge number of machines, but you need to store the useful seeds somewhere, especially if you want to use them, mute them, mutate them because they found some problems. And the basic option is as follows. You run a fuzzer. Hold on a second. Right. So you run a fuzzer on the seeds in the memory of the fuzzer. However, more complicated options include storing seeds in a folder or in a separate distributed database. Bullet 5, something that will keep track of your errors, and that's going back to the security policy. In order to detect an error, we need to discover it first. And I already told you what could go wrong when you use massive elements. The overflow error exists, but to identify it, you need a special code line, because you cannot just identify it by running a program which sums up something and gives you a value. You need to be able to match the error. There are tools to this effect, and scientific articles usually call them oracles. Other sources call them sanitizers, for instance, as is the case with LLVM. And last but not least, it's storing the test case.
разработчик
if we want to hand it over to the developer who will fix the problem. Discovering a problem is not enough. We need to explain to the person who wants to replicate it how to do that.
метод,
If you have a program and you have a method, then the best idea would be to generate a unit test that will be uploaded to a higher tracker. It will be provided to a developer. The developer will just copy and paste the test case, debug the program, understand what's happening, fix the problem, debug it, and test it again. And these test cases can always serve as a set of tests that their number will keep growing, and you will use them to make sure that the program keeps on operating well. Every of the bullets has its own name. So what we track? A program under test, method class, and the other under test. Well, and the articles usually use one of these names. The next one is what generates the values. So they are called generators, drivers, seed mutators, targets. Well, I'm going to give you more details on that later.
следующая информация про что нам нужно инструментатор и монитор.
Well, we also need instrumentator and monitors, and these are the tools that allow us to evaluate whether the incoming seed value is going to be useful.
Кстати, к слову, если
By the way,
у нас приходят два разных седа,
if you have two different seeds with two different values, but they follow the same path, what could be convenient in that case? Any ideas from the floor?
я никого не вижу, но
I don't see any hands raised, but dedupe and minimization are the two options used in fuzzing. I do understand that these are technical terms, but nevertheless, dedupe means that we match the behaviors, so they're the same, and we don't need the second seed. That's just the name. As for minimization, that's a more interesting process. We try to minimize the test cases, and to this effect, we match the incoming input values that result in the same behavior. Let's say you had a code line of 1,000 characters, and the second code line contained 100 characters. Of course, you would like to replace and use the code line with 100 characters because it's easier and simpler and more transparent.
не было понятия. Вот оно появилось, и снова ничего не понятно. Что это такое? И там сразу
When you get a name, you get confused because you don't understand what it stands for. People give you more mathematical equations. You have to analyze them and so on. Sanitizers, exceptions, and oracles are the next bullet. I already mentioned them. Test cases and unit tests, I also covered that point. As for the corpus, that's the storage for the seeds.
если начать погружаться в эту тематику,
If you deep dive into fuzzer,
на самом деле еще больше.
you'll see that there are more of the elements to a fuzzer. It's difficult to keep track of them, but
Понять, в чем между ними разница.
I hope that my presentation will help you understand the difference. Right, anyway, as for the internal components of a fuzzer, a different article
Различные применения
was published, and the authors tried to apply AI to fuzzer. I copied and pasted it more or less. So there is a generator, there's a program under test, there is a monitor, and the monitor is something that provides us data on the program operation. And the monitor has coverage or any runtime information that could be of interest to you.
информация про coverage.
The coverage data is sent to a mutator that mutates the values. And why such a flow chart? Why would a mutator need the coverage? A mutator wants to mutate values, but better than by substituting 2 bytes for another 2 bytes. So a mutator wants a convenient process, and all of these elements are in the inner workings. Well, the next stage would be the test case generator that generates input values for the monitor. And there are 2 other interesting boxes. When you generate seeds, there are lots of them. You get a corpus of seeds. And the fuzzing developers say, well, how do we select the seeds? Because there could be a million of them, but we only want those that with a high probability will result in new coverage. This part is just about that. You can use a complicated evaluation theory or an evaluation algorithm, but basically it selects values that will detect errors. And most of the articles about fuzzing are devoted to this particular part. Then we generate test cases. I guess it's clear-cut for everyone. Monitor can identify crashes or errors. And the last part is an attempt to evaluate whether our output data is really applicable. More complicated and more advanced fuzzers and researchers try to find vulnerabilities in the crash or an error. In other words, they try to use them to hack a system. And simpler fuzzers just detect errors in your program code. Oftentimes, I come across 2 main errors. Stack overflow, when for some reason your program takes too long, and it's up the entire stack. And the next error is out of memory. When the input is too huge, the program starts creating objects without a spinning out of control, which is not good. And this is the example about the lib fuzzer that I promised. So it's as follows. We deep dove into the inner workings of fuzzer. I told you how it functions, and I hope I managed to highlight some of the things that you've never heard before, because most of the authors just display this diagram, and you're still confused about what a fuzzer is. So let's take a fuzzer based on LLVM. They have an article on how to start using their fuzzer, which is built into the platform, so you can start using it from version 6 and up. All you need to do is write a program like that. It could have a name of a fuzz driver or a fuzz target. In their case, it's fuzz target. In Jazzer, it's the name used is fuzz driver, but basically it's a generator that allows you to translate the fuzzer language into the programming language, some of the random sequences. The lead fuzzer generates the random sequence. It goes to the code of natural numbers, and you can pick and choose various values and interpret them in any way you want. So after that, you need to compile the program, and you can use the clang. It turns out this is the right pronunciation, not clang. So anyway, you use the objective function to compile a program, and ultimately you get binary code, which is fuzzer. You run it, and it will ensure the fuzz target. So it will test your program under test, and it will use various advanced techniques, starting from the gray box fuzzing and up to smart seed selection to see what is happening. There are heat maps. There are other interesting buzzwords. Right, I already mentioned the corpus. Corpus contains values that are convenient for fuzzer to start on. For instance,
там,
if you test an image, it's more convenient to use a similar image.
и он же туда же, в этот корпус, будет потом еще...
And the fuzzer will feed some bad values into this corpus later on. And the things that I ignored are shown in the slide. I will briefly go over them and whether it will impact your willingness to try a fuzzer is, well, remains to be seen. Anyway, you have to run the program under test, and to do that you need to prepare some data. Minimally, you need to initialize a program and so on. And the most striking example is running your program in a Docker container, because, you know, it's inconvenient to use fuzzer to launch a Docker container, which will take a long time to initialize, then run your program within 10 milliseconds and provide you with the results. Therefore, there are different techniques that can save your time. Of course, you might want to cache something or
Очень простая. Чем
something else, but the faster you start up a program, the higher the probability that you will have to change the values of the global variables, and no one is going to stop that. From the viewpoint of a fuzzer, this is not business as usual. So you need to track that, and then sometimes it's unclear how to do that. The lib fuzzer says we're an advanced fuzzer. We can start up the main fuzzer, and when the program is ready for the startup, they use the fork technique to create sub-processes. These sub-processes feed the data back, and that means that both the program is not changed that much, and you save some time. But then again, there are lots of smart words such as in-process fuzzer. You can start them up in different nodes. For instance, you can start 100 fuzzers on different machines and so on. And the one thing that remains to be covered is the output. Since, well, again, to use a smart term, mutation-based coverage guided gray box fuzzer will write something like this. It contains info on the read. That's the first read of the corpus. Then it initiates and it finds 4 errors. This is the beginning of the expression because I was out of space, but it shows the mutations used by the fuzzer. For instance, change bit or copy part,
shuffle на массиве.
Shuffle the database, and so on.
Есть еще другие слова.
There are other smart words, but I mean, if you're an expert on LLVM, try to use this fuzzer. If you are not, use your own fuzzer to better understand what input data you need and what output data you might get. So I really hope that I managed to convince you that fuzzer is an easy and simple thing. This is a QR code for your feedback and for evaluating my presentation. Thank you so much for a brilliant presentation, for a brilliant talk. You refreshed my memory because I studied it back in college. You know, as fate would have it, we're short of time. So now we have time just for one question. I think that this is a general question, so I'm going to read it out, and this person is going to get a T-shirt as a prize. What's your take on the most promising work streams in developing fuzzing technologies, and what problems will they solve in the near future? Well, it's an awesome question. It's worth mentioning that one of the most interesting work streams that attracts universal attention is marrying machine learning learning and fuzzing. This is something that we rake our brains over, and you can tick every single box in my presentation to state that machine learning could be used to improve code generation. If if a fuzzer generates a code, it could be done by machine learning because AI technologies can generate any code, but there are more complicated things. However, I believe that everything related to mutations that could be used to refresh the corpus of seeds is the most challenging and the most interesting. We need to find a solution, and it's very science intensive because we have to apply statistics, probability theory, and so on. However, if used properly, it will identify mistakes way faster. We're talking about an order of multitude. We will speed up error detection 10 times if we use the right mutation mechanism. Thank you so much for a very detailed answer. And you were right in saying that if you sneeze, you won't be able to understand calculus. When I was in second grade, I missed some of my classes and I couldn't understand what they were talking about. Anyway, let's take other questions offline. Thank you so much for your attention. And please share